Okay, 5.1a, bisectors, medians, and altitudes in triangles. Objectives. Students will be able to identify perpendicular bisectors and angle bisectors in triangles and use medians and altitudes in triangles. So we're going to solve some problems using that. And right off the bat, I noticed that this picture here is not the right picture. I think I must have imported the wrong one. So I apologize for that. So let me just zoom out a little bit and I'll draw one over here. Okay, so let's say that I have a segment with endpoints. Okay, and then let's say I have a segment that bisects it, and I know this isn't right in the middle, but let's just say that it is. It bisects it perfectly, and it's perpendicular to it. And if I was to point and put another point somewhere on that segment, let's say, let's call it A. Well, I know that that point A is going to be an equal distance from both of those endpoints. It doesn't matter where I was to put it on this line here. It'll always be equal distance from both of these sides. So I could put it down here, call it B, and it'll still be equal distance from both of these. And that really is what the perpendicular bisector theorem is. It says if a point is on the perpendicular bisector of a segment, then it is equidistant. And that word just really means equal distance. That's all that means. So it's equidistance from the endpoints of the segment. So there we go. And the converse of that theorem is just the reverse, right? So it just says if a point is equidistant from the endpoints of a segment, then it is on the, I'm just going to use geometric symbols here, then it is on the perpendicular bisector of the segment. So there we go. That's our basic theorem. So let's take a look at that. Put that into practice here. Here we have an example. It says find the missing lengths. And sure enough, we have two lines that are perpendicular. And we know that this line is congruent to this line here. This segment is congruent to this segment. And so that means that point L here must be equidistant from O as it is from M. So if L to O is 7, then L to M must also be 7. So we could say, hey, LM equals 7. And same thing here. If ON is 9, N is on the perpendicular bisector, so it's got to be equal distance from both of these endpoints. So if ON is 9, then NM is 9. And there we go. We have the missing links. Now it says, now find the perimeter. Remember, perimeter just means the distance all the way around our shape or our polygon. And so this is pretty easy to calculate. We just add up these four numbers. Well, I think the easiest way to do is what's 7 plus 9? That's 16. And then you know this has to be 16 as well. So really it's just 16 times 2, or 16 plus 16, which is 32. There we go. And there'll be some more complicated problems, and we'll see them. But they might throw something in. They might throw something in like this, like, oh, okay, if this side is 9, what about if this side is, 2x plus 3, right? Can we solve for x, right? Well, we could just say, we could set it equal to 9, and then solve for x there. And I think you would get that x equals 3. So there will be more complications on that, but it's really just the same thing. We're just going to say, hey, this line is the same as that line. So we know we can set it equal to something else and then solve. And let's go on to theorem 5.4. This is the angle bisector theorem, and this one's pretty similar. But now we're talking about bisecting an angle, not necessarily a segment. And it says if a point is on the if a point is on the bisector of an angle, then the point is equidistant again. And the point is equidistant from the sides of the angle. Let me zoom in and show you what I mean by that now. Okay, so take a look here. here's my angle bisector. It bisected it right down the middle, so I know that angle 1 is congruent to angle 2. And I also know that means that this point S, right here on that side of the angle, and this point R on that side of the angle, if I was to go to any point here on this line, it will be equal distance. So SQ here is going to be the same as QR. But it does have to be perpendicular to this line in order for that to be true. So if these things will be, if these two things are perpendicular to our sides of the angles, so for example, if I was to draw a line from Q straight to this side, it has to be perpendicular in order for this to work. And Q straight to S has to be perpendicular to that side for it to work. So let me do the other definition, and then we can do a couple more examples so you can see what I'm talking about. Okay. Theorem 5.5, converse of the angle bisector theorem. If a point in the interior of an angle, so this is the same thing, it's just backwards. So if a point in the interior of an angle is equidistant from the sides of the angle, then the point is on the angle bisector. Okay, so let's do a little bit of practice this one. So we got a similar type of drawing here, a little bit bigger, but we can see, hey, we have B. It's obviously on the angle bisector because these two angles are marked to be congruent. So it's on the angle bisector. That means that B must be an equal distance from this side of the angle and from this side of the angle, as long as that distance is perpendicular to the angle, right? So that line BD is perpendicular to this side, and this line BC is perpendicular to this side. So that means that these two lengths are equal. So that means we can just set them equal. So I'm going to say x plus 7 equals 3x plus 3, and we're going to just solve. So I'm going to subtract x, and I'm going to subtract 3. And so let's just see what happens here when we do that, right? So these guys would cancel out. 7 minus 3 is 4. And 3x minus 1x is 2x. And now I'm just going to divide both sides by 2. And sure enough, I get that x equals 2. But this problem also wanted to know what the length of DB was. So here's DB, and it's also going to be the same thing as BC. And so we can just take x equals 2 and plug it in. So instead of x plus 7, we will now have 2 plus 7. This is what DB equals. And 2 plus 7 is, of course, 9. So there's the other answer. There we go. All right, so let's go ahead and switch over to the next page. Okay, practice number 2, given, and the computer didn't really let me type this all out, so I'm going to have to fill it in for you. So given that angle KLJ is congruent to angle MLJ, and angle K and angle M are right angles, find X, JK, and JM. So I'm going to let you guys do this problem, but first I want to just kind of fill in some of the information here into the drawing. So we know that this is a right angle because they say so, and this is a right angle because they say so. So just like in a proof, we're going to fill in all the stuff they tell me. And we know that KLJ is congruent with MLJ, so that means that these angles here are congruent. The iPad stylus doesn't really work super well all the time, so sorry it's a little sloppy. But that means that we should be able to solve for X and find JK and JM. So I want you guys to go ahead and do that. Press pause, and then I'll have the answer up there and see if you did it right. Okay, here's what you should have got. You should have gotten that X equals 12 and that JK is equal to JM, which is 17. So hopefully that's what you got. And yeah, let's move on. So now let's use this in the next drawing here. And again, I'm going to fill in the information. I got angle HJL, angle HGL, angle HKE, and angle HFE are all right angles. So let's just write that all in. HJL is this one, so that's a right angle. Angle HGL is this one, so that's a right angle. Angle HKE, that's this one, so that's a right angle. and angle HFE. That's that one, so that's a right angle. Okay, they want to know how is HL related to JHG. So here's HL, it's a ray, and we want to know how it's related to angle JHG. Well, it looks like since this line is perpendicular to this line and it's congruent to this line JL, which is also perpendicular to this side of the angle, then that means that HL must be its angle bisector. So if that's the case, we should be able to find y. So why don't you guys see if you can do that. Go ahead and try and do that. But basically, right, we do know that if these guys are congruent, then this distance from H to G should be equal to this distance from H to J. So go ahead and try and solve that problem and see what you get. Okay, hopefully if you solved it out, you knew you could set them equal to each other, and you would solve for y, and you should have gotten that y equals 9. And then if you kept going to try and find JH and HG, you know you could have just plugged it back in, and you would have found that these things equal 54. All right, good. That's basically it. You're going to do a lot more practice problems like that in class and in your homework, but you just need to know what parts are going to be congruent to what. So we know that this line is congruent to that line, this line is congruent to that line, these lines are congruent to each other. So lastly, why don't you guys try the summary where it says, what can you conclude about point E? And just try to explain to me how you know this for sure. So go ahead and give that a try, and you can ask me in class if you got it right. Okay, bye.